This is linear algebra 4.2. Last part of 4.2 is linear transformation. Previous video we discussed null space, column space. We're gonna define linear transformation this last part of 4.2. Okay, last part of this section is linear transformation, guys. So let's go over what is the definition of linear transformation. Here is the definition of linear transformation is right there, guys. V gonna be vector space, W gonna be vector space. So any vector space they're talking about, then you're gonna pick any vector from the V space. We're gonna find the T of X gonna be in the vector space W. It's like function, guys. Domain, you pick any number from the domain. So you're gonna assign the X value under the T function. So T of X gonna be W. That's we're gonna linear transformation, okay? So which condition you have satisfied for the linear transformation? Addition gonna be preserved under the transformation. So T U vector plus V vector, you're gonna have separate transformation. That's the first condition. Second condition is U vector times scalar multiplication, and then you send the T transformation. You're gonna do this one first. U vector go to the T, and then U times scalar multiplication. You preserve that transformation, preserves addition and scalar multiplication. That's we're gonna say linear transformation. Okay, so based on the linear transformation, you're gonna find the two subspace. First one is corner of T. Guys, corner of T definition is we're gonna find the vector in the V vector space. Okay, V. So T of U vector gonna be make a zero vector. That's V. Gonna say that space corner of T. So this, of course, this is null space, right? Subspace of V. Okay. Second is range. So you're gonna pick the any x value from the vector space. Then you're gonna find the value T of x. That should be W. That's correct. All the Tx with that gonna be range. So this one is subspace of W. So what are you gonna say, guys? Here is V vector space. Here is W space, vector space. You're gonna define the transformation is T. So here is corner space. Here is range of T. So corner is gonna be, you correct all the U vector, that's going to here, TU gonna be 0. Guys, that's not right. Corner space gonna be here. That's gonna be TU gonna be 0. Okay? So here is the range gonna be, you're gonna here find any x value here, any x value here, you're gonna find any x value here, you're gonna find here, T of x right there. That's gonna be defined corner and range, guys. All right, so we're gonna do, guys, I'm gonna do this example. So we're gonna practice how gonna show linear transformation. I'm gonna define T is polynomial with degree 2, guys. So this one is a polynomial with degree 2. So I'm gonna write down here A1, A0 plus A1T plus A2T square, A0, A1, A2 are real number. That's gonna be P2. That's polynomial. Correct all the polynomial. Quadratic polynomial is gonna be P2. You know the R2. That's the entry gonna be 2 in vector space. So we're gonna define translation is this way. P of 0 and the P prime of 0. So for example, I'm gonna put the if, guys, pick the any quadratic polynomial. You're gonna pick any one. T squared plus 3t plus 4. Then what is P of 0, guys? P of 0 is 4. Everyone see that? What is P prime T? Derivative of P of T is 2T plus 3. So P prime 0 gonna be 3. So the definition of transformation of T, so you're gonna see T, PT gonna be right here, guys. You're gonna see 4 and 3. That's how they find the transformation here, guys, right? Then we're gonna see this one is, we have proved this one is a linear transformation. Then you're gonna see addition of function and center transformation, you're gonna separate. Here is the scalar multiplication. You're gonna see T of P. That's we have proved, guys. That's a step forward, guys. Let's try this one. So let's try this one. Okay, so T, P plus Q. That's definition is what? Here, P plus Q and 0, P plus Q and derivative and 0. That's the definition, right? So what does this mean? P of 0 plus Q of 0. This one, derivative of function. That's separate. So this matrix addition, right? So what is this one? Transformation of P. What is this one? Transformation of Q. That's how to prove it. So you can use any sample the function, then you're gonna plug in exactly same way, guys. How about scalar multiplication? Let's go this one. TCP gonna be, meaning is CP0, CP prime 0. So this meaning is C, P of 0. C is constant. It doesn't impact by the derivative. C prime 0. So they all both have C, C, P of 0, P prime of 0, which meaning is CTP. Okay, that's extra way to prove T is gonna be linear transformation. Everyone understand how to prove linear transformation, right? Okay, last one is we're gonna find this spanning set for kernel T. What is kernel T, guys? Let's go kernel T. T definition is, you're gonna find the kernel T meaning is, guys, always you have to go back to definition. Kernel T meaning is you're gonna find the P polynomial in the P gonna be polynomial function with degree 2, then T, P gonna be 0. That's gonna be kernel T means, okay? So let's do this one and then we're gonna find the vectors, okay? Vector means you're gonna find the function, same meaning. So let's do the T. P gonna be degree 2 polynomial because that's the P2. So I'm gonna pick the any P in the P2. So you're gonna P anything. Right? So what is definition of T of P? Definition of P of T gonna be P of 0, P prime of 0, right? So let's find this one. P of 0 gonna be C. Let's find the P prime T, 2AT plus B. So P prime 0 gonna be B. So we find it. Imagine of the P under the T, so this one is a C, this one is B. This vector gonna be what? 0 vector. This should be 0 and 0. So two vector is the same, so you're gonna see C should be 0, B should be 0. Now, PT gonna be PT is should be kernel T gonna be C gonna be 0, B gonna be 0. What do you have here? A T square. Everybody make sense? So polynomial gonna be kernel T, meaning is A times T square. A is any real number. Okay? So what are you gonna say? So kernel T gonna be span with T square. So any real number times T square gonna be should be in the kernel. That's what they're talking about here.